last problem, which is dealing with a strained rosette. So don't get spun right around. Keep your angles consistent. So I accidentally tore my piece of saran wrap in the previous problem. Low density polyethylene is a thermoset. So place the two pieces close to one another, put it in an oven, increase the temperature below the TG. It's able to self-heal, but now I want to know the stress state near this fracture. So I put the rectangular rosette, so in green, near the fracture line as shown below. So I measure in my rectangular rosette, the EB arm and EC arm are these values here. I also place a delta rosette. So I have my, I'm going to call this my rectangular rosette A, B, and C. And it says here I put a delta rosette with the A arm rotated 5 degrees clockwise from the A arm of the rectangular rosette. So my A prime is right here, and this is 5 degrees. So I also know that I have my B arm. Again, I'm just going to draw it exaggerated. B prime and C prime. So looking at this problem, and I actually have this value here. So I have a Moore circle. So I have my gamma in strain space, gamma over 2. I have my strains. So this is, I have my EC, EB, and EA prime right here. So there's some center, again, it's going to do, my circle is going to intersect these somehow, some way. So I'm going to choose as my reference, actually, not the C, but the A. So this right here. So there's going to be some center, there's going to be this 2 theta value here, and this EA prime. So I'm going to write out my EA prime is equal to C plus R times cosine of 2 theta. And then I know from that, I can kind of write out the rest of these values, right? I know then that actually we'll calculate that in order to figure that out. So my EB arm, so my EB equals C plus R cosine of 2 theta. And then what's the angle here? So between A prime, so it's 5 plus 45. So it's going to be, again, we're moving counterclockwise, so that's positive. So if I'm for my rectangular rosette, it's going to be plus 2 times 50 degrees. And my EC is equal to C plus R times cosine of 2 theta plus 2 times, again, it'll be from here, 5, and then 90. So it'll be 2 times 95. That's it. So with those 3 equations, I know those values, and now I can figure out and solve for my EB prime and EC prime once I get, and also EA. I could solve for that once I get CR and theta. So let's go ahead and calculate that out. So, problem here. So let's go ahead, actually, let me delete all of this. Delete, quit kernel. Here we go. Yes, I want to quit. So I need to first define my values. So EB is equal to 0. Let's make sure I get the right zeros. 1, 2, 3, 4 zeros. 3, 7. EC is equal to 0 0.1234, 2, and EA is equal to EA. I'm going to call it EAP, EA prime. So I'm going to write that right here on my EA prime. I'm going to call it there. So let's go ahead and back. EA prime is going to be equal to 0 0.1234. I already have that. 53. So calculate those out. Let that run. I'm going to solve the system equations where EAP set it equal to C plus R times cosine of 2 times theta in degree mode. And then I'm also going to have this on. I'll just shrink this a little bit so I can see that angle. This and this. So this will be EB. Again, I have to do these angles relative to where I choose my reference. So I'm starting from here. Now I need to kind of see. Again, it's moving this kind of counterclockwise. So 2 theta plus 2 times 50 degrees. And we do the same thing here. CR theta. I need to put this value right here. So 2 theta. Then it's going to be plus 2 times 95. So we'll put that in parentheses too. All right. And let's see, hopefully that closes it. 2 theta, everything here is a copacetic. Let's go ahead and numerically solve that. So let's go ahead and look at, actually, let's do numerical solve. And let's go ahead and see our solution here. So as we can see, I have my center. So my center is going to be equal to here. Those are both equal to one another. And now here's the key trick, or not the key trick, but the key point. I chose here, this was my reference point. So my center, I need to add a radius. If I chose this, I would have to subtract that radius. So I need to add, so I need to choose a positive radius. So my radius equals this. If that is my radius, then I will find that my theta angle must be equal to here. That's it. So that is my theta. So let's actually look at those values. This minus 10 degrees. All right, so now I have to figure out what is my EB prime. Well, I know for a place of delta Rosette, if I put a delta Rosette, because that's my EA prime, my delta Rosette angles between B prime and C prime are just going to be simply my EB prime. EBP is just going to be center plus radius times cosine of 2 times theta plus 120 degree here. Let me go ahead and close that. This and like this. I know that my EC prime will just be, excuse me, C plus R cosine of 2 times theta plus 240. Those are the angles from our delta Rosette. And then finally, my EA in the rectangular, excuse me, will be R times cosine of 2 times theta. And then it will be, because we are looking at that rotation that is going to be clockwise from the EA prime, as we can kind of see right here. So we have that clockwise angle of 5, so it's just going to be plus 10 degree. And that's it. So those are your values that you'll get. So hopefully that was helpful. Again, make sure you kind of put that parentheses around them as well. But that's how you're going to kind of essentially write out all the values for this problem. So excellent. Thanks and good luck on your exam.